Hello, this is a recorded IronRidge training presentation. I'm glad you could make time to join in and learn a little bit about Roof Mount from IronRidge and the IronRidge Design Assistant tool for Roof Mount. My name's Dan Felix. I work at IronRidge as the training manager, and truly my background is as an installing contractor. I had my own electrical contracting firm for 17 years installing solar, then went to work for a nationwide integrator installing very large utility scale and very large commercial solar projects for about 5 years. I'm here at IronRidge now working as the training manager and glad to share different tips and tricks I've learned over the years installing solar and definitely teaching you all about the IronRidge product line. Pretty interesting, about the time I started in the solar industry, maybe just a little bit later, Craig Carney, the founder of IronRidge, he actually started working at developing some solar racking systems. People from his local community were coming to him, much like myself back in those days. They knew that Craig had a background as a steel worker and a structural engineer. People were coming to Craig asking if Craig could help them design or figure out some way of mounting solar panels. Truly, I was in the same position in those beginning years. We were using unistrut and spring nuts and anything we could come up with from basically the electrical industry to mount solar panels. Truly, that's what inspired Craig to start the company IronRidge and develop the great racking system that IronRidge has here to offer you. Here at IronRidge, we stay pretty diversified any way we can. One of the ways we do that is just in the manufacturing of our products. Stringent on ourselves with maintaining a very high quality to our product. In that costs money, and we're constantly looking at ways that we can also go ahead and reduce the cost of our products and be very competitive cost-wise in the overall solar industry marketplace. One of the ways that we can actually reduce the cost of our product to the end user is by manufacturing in many locations nationwide, and this allows us then to reduce the shipping cost to the end user's location. Just a simple way that we can minimize the cost of our product for you to use out there in the solar industry. We have three separate major lines for our solar racking systems. We have roof mount, we have ground mount, and we have pole mount. I talked a minute ago about quality, and when I talk about quality of our product, it's not just IronRidge patting ourselves on the back saying we make a great quality product. We like to validate that in many different ways. One of the ways that we prove the quality of our product is actually taking it to third-party companies for their evaluation. Anything to do with UL testing, could be the fire testing, or it could be the integrated grounding system. We take to Intertech for all of our UL testing. We utilize IATMO, a third-party evaluation service, to evaluate our product and the performance of that product. We are an ISO certified company. If you're not familiar with ISO, it's a third-party organization that's not only looking at our product, but they're looking at how we interact with the end user of our products. They look at how we're packaging our products, how we ship our product. They're looking at our overall office procedures here at IronRidge, and we are an ISO certified company. We used to have a tagline saying, "Make solar simple." Truly, we strive for having a very simple product to use out in the solar industry. In the same token, we really want to have a very robust, strong product as well. Truly, that's our goal, is to make solar stronger. So we changed our tagline last year. We want to provide you with the strongest racking system available out there in the marketplace. So in today's training, I want to go over a few different items. We definitely should take a look at just a roof system itself and some of the challenges maybe with roof mounting. I want to touch a little bit on the code. We'll hit on a hot topic here in California with code. We want to look at the IronRidge product line itself for roof mount, and then we will spend some time on the Design Assistant tool, and we'll design a system on the tool to actually show you how that tool works. Awesome tool. Then we'll go through some installation tips and tricks that I've learned over the years I'd like to share with you. And definitely, this being a recorded training presentation, it makes it very difficult for questions and answers. But I do encourage you to go ahead and call our tech support group at IronRidge and ask them any questions that you might have. The tech support group will be definitely glad to help you. Challenges in roof mounting. Let's take a look at a few of these items. What's in a roof? When we look at a roof system on a structure, we want it to be waterproofing, we want it to be fire resistant, and we want it to have a good structural strength to protect the contents of our structure. As we start thinking about applying solar to this roof structure, we want the same functions. As we're mounting our racking system onto a roof to build our solar system, we want to go ahead, we want to maintain that waterproofing ability of that roof. We want to definitely maintain the fire resistance of the roofing, And we want to have a very strong structural strength as we add this loading component of the solar system to that roof. But we're going to add a new element, and that's going to be electrical safety that we need to be thinking of as well. Pretty interesting getting into the solar industry. I got into the solar industry as an electrical contractor. Figured this is my bag of tricks. I really know how to do everything in the electrical industry. Solar, we're going to go ahead and produce electricity. This is going to be perfect for me to get into. And truly, as I got into the solar industry and started building some of my first systems, I started realizing there's a lot more to this than just electrical that I really need to be paying attention to. Truly, where you really need to be looking at a lot of different codes besides just the NEC. You need to be looking at international building codes as far as requirements on waterproofing your penetrations in a roof. You need to be thinking about fire codes, keeping a good array dimension to promote fighting access to the roof. You need to be thinking about the latest building codes dealing with some fire issues, and we'll review that a little bit. ASC 710, the latest structural engineering codes. Definitely should be thinking about that, have some knowledge with it. And the NEC, obviously, the National Electric Codes. We need to have a good understanding of all the NEC codes as we're wiring and building an electrical power plant. The one code topic I do want to touch on in this training presentation is some of the fire protection principles. We want to definitely prevent ignition. We think about that with developing a solar system. Definitely we want to be sizing our wire properly for whatever electrical transmission trying to generate. But if a fire were to start within the structure, we definitely want the design of our solar system to resist spread of fire. We definitely want to design our array layouts to support local firefighting communities. What's really a hot topic right now in California and will become nationwide next year, 2016, is the code changes. International Building Code actually changed in 2012. Just now in 2015, we're here in California adopted enforcing this code. And that's basically stating that a PV system shall not diminish the fire rating of the roofing material on the structure. The key word there is system. In the past, it used to be the PV modules had to have a fire rating. Now it's the entire system. That includes the racking, must also have a fire classification rating. What it boils down to is if you have a Class A fire rated material for your waterproofing membrane of your structure, the installation of the solar system must not diminish the fire rating classification of the waterproofing membrane or the roofing material on the structure. As you think of that, truly I want to let you know that here at IronRidge we've been proactive with this. As soon as UL set the testing standard, we jumped right into working at having our racking system tested under this new code requirement. We've completed 3 rounds of testing now with steep slope roofs, flush to roof or tilt mounted. We carry a Class A fire rating for Type 1 and Type 2 modules. If you're mounting flush to roof, we are also Class A fire rated for a Type 3 module on steep slope. On your low slope roofs, we are Class A fire rated for flush mounting or tilt up system for Type 1, Type 2, and Type 3 modules. As I was saying earlier, it's pretty amazing as you get into the solar industry, everything that the solar designer or solar installer needs to be knowledgeable of. It's so much more than just the NEC or the electrical code. We need to be knowledgeable of what Mother Nature is going to throw out there at that location as far as wind loading and snow loading. Definitely need to know the geographical situation and what's there for loading conditions. NEC, I'm an electrical contractor. I'm a perfect fit for this, no problem there, but I do need to be knowledgeable with the modules that I'm using, what they produce for power, what inverters I'm going to use, the proper sizing of my wiring for my inverters and modules, and definitely be following codes with how I'm going to install my wiring. I need to have a structural background. I really need to be thinking about the framing of the structure, the spacing between the rafters, maybe just the spans that those rafters are performing in that structure, and what the acceptable loading is going to be as I add a solar system to that structure. Got to be a roofing contractor now. Got to put on the roofing contractor's hat and really be thinking about that. Truly, I need to be knowledgeable with the different types of roofing materials, utilizing the proper flashing to waterproof my penetrations that I'm going to put in this waterproofing membrane of this structure. I have to have a mechanical background. I have to really be thinking about how the racking system assembles and that I'm tightening down all the attachment points properly, torquing things down to a proper torque level that's going to maintain and hold that system system there for the life of the system, hopefully for years and years to come. I need to know about the local jurisdiction. I need to know, what's it going to be involved in getting a permit for my solar system at this location. At the local jurisdiction, I need to find out if they have an expedited permit process, maybe where I could follow their guidelines for that expedited permit process and go in and get a permit right across the counter in one day. Or maybe the building department does not have an expedited permit process, and I need to be really knowledgeable with what the jurisdiction is going to require for obtaining that permit, even with the permit review process, minimizing the time back and forth with the building department to obtain that permit, making sure I'm going into the building department with everything they need right from the very first application for my project to make a quick turnaround time to get that permit. So let's go ahead and take a look at the IronRidge product line itself. Earlier I had noted that at IronRidge our tagline used to be "Make Solar Simple," and truly we strive to maintain that as well. And when you look at our product for roof mount, it is a very simple product. We have an integrated grounding mid clamp for attaching the module to the rail. We have 3 rails in a rail family that I'll tell you about. And then we have a great flashing product, an all-in-one flashing product which will make a very quick installation of your attachments to the structure. In the development of our products for roof mount here at IronRidge, we strive to have a code-compliant product that you can use nationwide. So a minute ago I talked about the rail family we have here at IronRidge. We have the XR1000, the XR100, and the XR10. You truly now have a choice in the rail family to choose a rail that's going to be most cost effective for the loading conditions of the site you're designing for. Possibly it's not just the loading conditions, but maybe it's the structure you're working with for installing a solar system or designing a solar system for. That XR1000 rail, it used to be called the XRS rail, and we've renamed it in the new rail family now as the XR1000, but it was our signature rail for years. This body shape adds a lot of vertical and lateral strength to our product. So we went ahead and we added 2 new rails to our product line, the XR100 and XR10, each a little bit smaller in rail size to work with whatever the loading conditions are and be able to utilize the most cost-effective rail. Interesting to note is that as you're installing solar systems, you're not installing them flat. Truly, you're putting them on a sloped roof, or in a low slope roof application, you're putting them up on tilt legs. But in all of these applications, you're putting them up on an angle. And truly, that's where the body shape of our rail adds a lot of strength to the overall installation and attachment of your solar system to the structure. This body shape adds a lot of vertical and lateral strength that resists twisting, and also is going to really hold well as you're installing on these sloped conditions. Kind of interesting, we had a little fun at the shop at IronRidge one day. We went ahead and built some ramps at a 4-foot spacing, and then tried driving different weight vehicles across different rail just to prove the strength of that body shape. Obviously this was a non-scientific test, but it was a lot of fun actually proving the fact just by driving different weight vehicles across our IronRidge body shape rail compared to the traditional box shape rails available in the marketplace. Just if you get time, go to our website and watch the video. It was a lot of fun making the video and actually proving the point. My 9,000-pound Dodge diesel truck driving across some IronRidge rail at a 4-foot spacing. Phenomenal, the strength in that body shape. Alright, so as we keep talking about all this strength of our product, we need to be thinking about the value of this strength that we keep talking about. And it really plays out in 2 different ways. One of these is the spans that you can achieve between your attachment points in the structure. Obviously, the longer the spacing between your attachments or the spans of the rail, you will be able to design a system that has fewer attachment points in your project. The other option in the strength of our product is utilizing what we call the cantilever strength, and we'll go over both of these here in just a minute. Just note, if you don't understand cantilever is the amount of rail that can extend beyond the last attachment point in the structure. So as we're looking at the XR10 rail at a 4-foot spacing between the attachments, and we start comparing that to possibly other applications, it's pretty cost effective in utilizing this XR10 rail. I call it our small baby rail, at a 4-foot spacing in the attachments. When you compare that to maybe doing a 6-foot spacing of the attachments. Yes, that XR10 rail can even achieve up to 6-foot spacing on the attachments. Truly, we can reduce the cost by about 6 cents a watt. These are all suggested manufacturer resale price, so just be aware of that. We use suggested manufacturer resale price as a level playing field in comparison, but truly you're going to get a great discount from any one of our distributing partners on our product. So as you start thinking about maybe wanting to achieve maybe an 8-foot spacing between your attachments, that's where I would step up. Go to that XR100 rail and then go ahead with an 8-foot planning and design in your project. You start thinking about the added cost going to that larger rail, that XR100 rail. Your cost has only gone up a penny a watt because you've reduced the number of attachments in your project. So obviously you've reduced your labor as well as the material. So I spoke a minute ago about the cantilever strengths of our product. In all of the body shape in our rail family and that strength that we have in the product of the rail family, this is where you should be thinking about utilizing the cantilever strength of our rail. As you start thinking about going to a 6-foot spacing between your attachments, as you increase the distance between your attachments, you're increasing to what we call point loading to the structure. Truly to turn it back into a distributed loading as much as possible with increasing the spacing of our attachments. We want to be thinking about staggering our attachments in a project if we can. This is where that cantilever strength of our product becomes very valuable. Truly in 2 rails in a row of modules, as per the bottom illustration here, we can start one rail with an attachment right at the end of the rail. On our second rail in that row of modules, start the first attachment 1 rafter space in. Then continue the spacing of your attachments as per your design, and this is going to go ahead and give you a staggered attachment in your overall row of modules. It's going to be placing the loading to multiple rafters within that structure, turning it into a very distributed loading situation. Much better for the structure. There's 2 ways that we can utilize this cantilever strength. If we're doing a fairly minimal spacing between our attachments, like 6 feet, we may want to go ahead and cantilever both of our rails in a row of modules, minimizing the total number of attachments overall. Or your other option is to use that cantilever strength in one of your 2 rails in a row of modules and just do what we call a staggered attachment as per the bottom illustration. Obviously the illustration at the top is going to completely minimize the number of attachments, where the illustration below is going to minimize some of your attachments but provide a very good distributed loading to the structure. Interesting when you look at some studies that have been done recently with overall labor statistics to installing a solar system. And truly in these studies what they're finding is the amount of time it takes to install the attachments, to go ahead and lay out your rafters, locate the rafters, get your flashings installed properly to waterproof your penetrations, seems to be one of the largest labor items in installing a solar system. So once again, I want to show you, no need to memorize this chart. When we get into the design tool is going to provide all this information for you. When we look at the different rails in the rail family, the XR10, XR100, or XR1000, this chart represents some of the spanning capabilities with different loading conditions. Just remember that XR10 rail is going to be the awesome rail to use if you have minimal snow loading and minimal wind loading. As you go to a location that has maybe some stronger wind forces or some snow loading, move up to that XR100 rail. Or maybe it's just the spacing you're wanting to achieve in your attachments. Maybe you have very minimal loading, but you want to go to an 8-foot spacing in your attachments. That XR100 rail will be your rail of choice. And then I always talk about the XR1000 as our big bad boy rail. Truly a very phenomenal rail. This rail can span 10 to 12 feet between the attachments. Maybe your rail of choice for a commercial application where you're trying to reach 10 or 12 feet out for your spacing to attach to main purlins in a project. Possibly you've got some extreme loading conditions. Maybe you're on the east coast to the far north and you've got 80 pounds per square foot of snow loading. And maybe you've got extreme wind loading conditions. Maybe you're in hurricane territory where you've got 150 mile an hour winds. that XR1000 is going to be your rail of choice, whether you're at extreme loading conditions and still doing a 6 to 8 foot spacing between your attachments, or that commercial project trying to reach out 10 or 12 feet to your attachments. FlashFoot. Truly, it's an all-in-one flashing attachment, and it has a great 20-year warranty with it. When you look at our flashing attachment, it has an L-foot with a cone shape. This cone shape is going to compress over a rubber bushing that's in our flashing, and it's going to compress that rubber bushing against the bottom of the L-foot, against the flashing itself, and it's going to compress that rubber bushing around the diameter of the shank of that lag bolt, totally sealing off your penetration that you're placing in the roof. What's really nice about the design, I know a lot of people are a little hesitant with a flashing that has any rubber parts in it, but the way this is designed, that rubber bushing is totally concealed underneath the L-foot, which totally eliminates the rubber bushing from ever seeing any sunlight or air pollution that can break it down over time. So it's very long lasting. Remember, this has a 20-year warranty to it. The other great feature with our flashing attachment is truly being all-in-one. It installs very rapidly. If you use chalk line to go ahead and chalk out your attachment locations, we have some creases that increase the strength of the flashing itself, but are also designed to act as a guide to show you where to place that flashing. No putting your head against a hot roof to look for that tip of the lag bolt and where it has to enter that pilot hole. Truly, if you use a chalk line, you can use these guide marks on the flashing to install the flashing directly over your pilot hole location. But then you're going to put your lag bolt through the L-foot and go ahead and use your battery impact gun and drive that lag bolt into the rafter. Once it's tightened down, it's ready for rail. And truly unique is our open slot L-foot, truly making it a very rapid installation of the rail to the L-foot. When you look at the different steps that are generally involved with installing a flashing attachment, our flashing attachment, FlashFoot, has eliminated 4 different steps basically in most flashing attachment installations, definitely reducing your labor as you're installing your flashing products. When you look at the overall strength of our flashing in the attachment to the structure, we're side by side with one manufacturer. The two of us are truly the strongest flashing attachments in the overall solar industry. It's almost kind of scary when you start looking at some of the other flashing attachment third-party companies out there and what the strengths of their products are to the attachment of the structure. Integrated grounding, awesome, simple product, and yet it truly is just great at providing that electrical grounding and bonding connection of the modules to the mounting hardware. Like I said, very simple product. It's a mid clamp with some teeth in it. These teeth bite into the anodization of the module frame that's going to provide a good electrical bonding connection from module frame to module frame, and then it transfers that grounding and bonding connection through a serrated flange nut into the bolt. On that T-bolt, we've added some teeth to bite through the anodization of our rail and provide that grounding and bonding effect then from the module frame to the rails. All of the IronRidge rails are anodized to protect them from corrosion. Just truly a very simple product, but yet very effective in the performance that it's built for. The benefits of integrated grounding, you know, so many people just immediately think, no more weave clips, and they're just thankful of that. But truly, the integrated grounding system does much more than just get rid of the weave clips. It eliminates 50% of your rail bonding and eliminates 50% of your splice bonding. So, and just all the multiple parallel paths of bonding now through those mid clamps provides a much better, more robust, strong grounding bonding condition than we ever had in the past. This can show you right here in your 2 rails in a row of modules. You only need to place an earth ground connection on one of those 2 rails. Whichever rail you choose to place the earth ground connection to with a lay-in lug, if you have a splice in that overall length of rail, you'll place a bonding jumper at that splice location. In this, the second rail in your row of modules no longer needs an earth ground connection and no longer needs any bonding jumpers at the splice locations. So right off, you can see being 10 to 15% fewer parts depending on the array layout of your design. Obviously, fewer parts, less cost in materials. Obviously, fewer parts, less labor as you're installing your system. All right, design and permitting. So as we get ready to go out and actually start thinking about selling a solar system, we're going to go out and do a site survey. We're going to go ahead and we're going to get educated on what the local code requirements are going to be with jurisdiction as far as designing that system. And then we're going to go ahead and come up with our array layout design. And then we're going to go ahead and start thinking about everything that we need to provide to that building department for that permit package. At this point, I want to go ahead and get on our Design Assistant tool and show you how to go ahead and design a system on our tool. The Design Assistant tool from IronRidge is just awesome. It does so much for you. It's going to auto-calculate your wind loads and snow loads. It's going to generate a complete bill of materials for you, and it's going to provide instantaneous pricing in the design tool so that as you're choosing between the different rails in the rail family, or maybe the spacing between your attachments and the number of attachments in your project, you can select and make choices that are going to be the best pricing possible for you in your design. So I'm going to take us live onto our website now, and we'll actually go ahead and design a system here quickly. Alright, we've gone live onto the website here at IronRidge, and on the opening screen it'll scroll through some different items that are new to IronRidge that we want you to be aware of. Yeah, the ground mount, we can do 5 up now. The new rail family available here. So just kind of some interesting notes as it scrolls through the opening page here at the opening page of the website. You'll notice the different product lines listed at the top of the page. Also take note at the bottom of the opening page of our website, you can download a parts catalog. You can open a tool that shows you how to use Design Assistant. You can actually, on webinars, go ahead and see what other training events I have coming up as live training events and webinars. Be glad to have you join in on some of those as you have time. Great information here on the opening page, but we're going to go right to the roof mount product line, and we're going to click on roof mount, and you'll notice that right off it's going to go through some overview items which we pretty much have covered already. Kind of a neat 360 view here. There's a toolbar off to the left. If you click on that 360 view, it's going to bring you to a point to where you have a compass off to the right. Kind of interesting. You can click on different compass headings here and look at a system from different angles. You can add on the solar panels here. Maybe you're going to do a tilt-up system and you want to see what it's going to look like with the tilt legs. Scroll that around and look at it from different angles. See how the product assembles, and kind of a nice tool here. I've heard that some people like utilizing this actually as a sales tool with their customers when they're meeting them for the first time, showing them what the IronRidge product line is going to look like as it's installed. Next item down on this toolbar is features. Some different items there that we've already gone over. The rail family. This is where you can look at that video comparing the body shape of our rail and different weight vehicles driving across those rails if you want to take a look at that video. Some information on FlashFoot, pretty much items we've covered already. Next item down on that toolbar is training. This is just going to take you to that same site where you can see my upcoming training events and live public webinar broadcasts that are coming up. Resources, the next item down on the toolbar. There's a great amount of resources here for you as you're getting ready to go to the building department. We'll also find most of these items on what we call the next steps page in the design tool, but truly there's some items here that you may not find at that next steps page. Maybe you're wanting to really look like the solar professional going into that building department. Go ahead and print out some of our documents for integrated grounding. Print out some of the documents on FlashFoot or possibly our fire testing to provide all of that as part of your documentation in your permit package. Also, what we have here available is cut sheets. We have all of our different product lines for roof mount listed here. You can go ahead and click on a specific product like grounding mid clamp, hit download, and it's going to give you an overview of that product, giving you all of the dimensions of that product, all of the materials that that product is made out of. So just some great information here as you're looking maybe for some physical dimensions of some of the different product lines. So So just take note that that's available here for you as well. Below that, we have certification letters. We have a third-party engineering group that we're going to provide you an engineering document to have as part of your permit package. Go ahead and choose whatever state you're located in. We have 38 states and 3 countries available here. I'll go ahead and click on California because that's where I'm located. Let's just say we're doing a XR100 flush to roof and hit download, and it's going to provide you a third-party engineering document. It's going to have a cover page. It's going to go through a series of charts. Go ahead and print out the charts that are pertinent to your design, and then we actually have a stamped document page, a final page in the engineering document, where you can actually provide this as a document in your permit package showing you have engineering review of your project. Below that, we actually have some detailed drawings that are very useful to not only have as part of your permit package, but then to also print out and have with your installers out in the field as they're installing the system and calling for inspections. An inspector may question how something is installed, and you can show them in the detailed drawings that it's installed exactly as per the manufacturer's requirement. Should alleviate any problems with your inspector out on the job site. So great resource here for you as you're moving forward with your design. So let's actually get into building a design here. Next item down, we're going to click on Design Assistant. Virtually anyone can get on our design tool and utilize the tool. There's no charge for using our tool, but truly I suggest that you open an account with IronRidge for using the tool, because by opening an account you can do quite a bit more. There's no charge for opening that account with IronRidge, but if you open that account, it allows you to save your projects and it allows you to share your projects. Really important as you do design for a system or for a customer. As you do a design for a customer and want to take that back out, sell the project to the customer may really like your pricing and decide he wants to actually go larger with his solar system, or maybe he wants to, reduce the size of the system. If you've saved your project, it makes it very easy to go back and very quickly make some adjustments to the first design and then go back to the customer with a final pricing and final design for the project. Having that account also allows you to share your projects as well. When you share your projects here at IronRidge, you don't share them out across the internet. You share them in a private location here on the IronRidge website. So your projects are very well protected. The only people that'll be able to view your projects is the people that you input their email address and select the people that'll be able to view your project. First thing we need to do is give your project a name. I'm going to go ahead and just give a name John Doe for today. This item down in your design tool is giving us information with what module you're going to utilize in your design. We have over 2,500 different modules to choose from here. Truly just a huge number of modules. If you happen to be utilizing a module that's not shown on the tool, note here that we have our customer support phone number here, 1-800-227-9523. Go ahead and call our tech support group. If you can provide them a cut sheet for the module, literally within sometimes only an hour, the tech support group can get that module added to the design tool. Just take note of that. For today though, I think I'll just choose a Solar World module. Once you've chosen the manufacturer of the module that you're utilizing, then you need to actually choose the module from that manufacturer. So huge number of modules we have available. I'm just randomly going to go ahead and choose like a 280 watt module for the training today. Another item you should look at, and that's the physical dimensions that we give you of that module. Just double check, make sure those dimensions are correct. If for some reason you see that the dimensions are not correct, please call our tech support group and notify them. We'll get that corrected. This item down in the design tool is planning your array layout. Just take note that on orientation, when we talk about portrait or landscape, when we talk about landscape, we're talking about the long side of the module parallel with your rails. When we talk about mounting and portrait, we're talking about the long side of the module being across the two rails in a row of modules. We're not talking about consideration to the ground or to the roof or anything else. We're always talking about landscape or portrait being in consideration to the rail. So just take note of that. Also, you'll note that I clicked on these question marks, and that's how I achieved those answers. Just note that these question marks are throughout the design tool. If you're not understanding what we're asking of you, you can always click on those question marks, and it's going to give you an explanation such as this being rows of modules. Rows of modules are modules side by side on two rails. All right, so just take note of that. In today's training, let's do, let's do 6 modules and let's do 4 rows of that. We'll leave these in portrait, and in this design, let's say that with this roof, there's maybe some room along the bottom edge by the gutter line where we could place another row of modules, but there's not enough room to put these in portrait. So I can add a subarray, and let's go ahead and add some more modules in here. Let's say 4 modules in one row, but we're going to do these in landscape. So I'm just showing you that you can design in portrait or in landscape. One thing that you should note is that with module manufacturers now going to smaller frame sizes, there are some module manufacturers that do not allow their modules to be mounted in landscape. So be sure to check with the module manufacturer if they allow their modules being mounted in landscape. Literally, this program is very flexible. You can keep adding more and more subarrays. Possibly this first array section is on a south-facing slope of the structure, and you're wanting to design another array area that's on a west-facing slope of that same structure. Truly, you can keep adding more and more subarrays if needed. I'm going to go ahead and just leave it right now. We're going to build this one array area. We've got 6 modules in a row. We've got 4 rows of that, all of these in portrait, and then I've got 4 more modules mounted in landscape in one row, maybe at the bottom or maybe at the top of the array area. Next item down in the design tool is the mounting style. For today's training, I'm going to leave it in flush mount, but if you choose tilt mount at this location, on the next page of the design tool, the engineering page, input the slope of the existing roof, the tilt angle that you wish to mount the modules at, and the design tool on the engineering page will auto calculate exactly the size tilt leg you need for your install. But for today's training, I'm going to leave this on flush mount, and we'll mount flush to roof in this design today. As we scroll down, a couple things I want to note here. At the top of the page, you have a toolbox up here that's updating as we're putting information in. Kind of a nice little feature to have in the fact that saves you from doing some math. Maybe you were trying to design a system that was 7.5 kW or something to offset the electrical usage of the customer. You can see right off we give you the total wattage that you have in your design at the moment. We give you the number of attachment points, 60 attachments. I don't like that too much, but we're going to play around with that on the engineering page. We have a total of 28 modules. We also have a cost factor here. This cost factor is suggested manufacturer resale price at this point in time, and I'll show you a little bit further in the design tool how we can play with that a little bit to adjust the cost. At the bottom of the page we have the next selection, and that's our engineering page. As we start on the engineering page, first thing we need to do is give this job site a location. So I'm going to give it my zip code area, and by entering the zip code it's going to know right off what city I'm located in and what state I'm located in. So I'm in Modesto, California, Central California area, Central Valley area, and it knows from that what the local jurisdiction is requiring for loading conditions of the design. So down under snow and wind, further down in the engineering page, it's auto-filled that I need to design to 100-mile-an-hour wind speed and that I have 0 snow loading at this location to design to. Now, something to note with this, and that's the fact I used to build a lot of solar systems in the Sierra foothills area of California, and in that zip code area, I could be building a site that was at a 500-foot elevation, or I could be building a site that was up towards Lake Tahoe, all the way up at about 5,000-foot elevation. Be a little bit careful with the zip code autofill of your loading conditions. If you're happening to be designing a system in an area such as the Sierra foothills where you have a large elevation change, or if you have some very large deep canyon areas where it could have very high winds, I would suggest that you call the local jurisdiction, the permit or building department, and actually check with them with a street address the loading conditions that you need to design to for this project. Next item down is the building details. Let's say this is just a single-story structure. The ridge of the roof is no higher than 25 feet. We'll put that in there. The existing slope of the structure. I'm going to just say in California, a lot of our structures are at about an 18-degree slope. I'm going to go ahead and put that in there. This is where, if you were doing a tilt-up system, you would be placing in here, you'd have another box to fill, and that would be the tilt angle that you desire to have the modules at. But we're not doing tilt up today, we're just doing flush to roof for this training event. The next item is wind exposure. Remember, we have these question marks in here. If you're not understanding about wind exposure and what we're asking of you, you can always click on the question mark, and we're going to give an explanation of different wind exposure situations. So here in Modesto, in the farmland area that I'm living in, truly I could be building a solar site on a building that's in a residential area with plenty of houses and trees and buildings around within a 3-mile radius to break up wind in a storm event, which would put me in exposure B type category. I could be building this on a farmer's home out in some open farmland with no buildings or trees around me for a 3-mile radius that would easily put me into an exposure C type category. So just get an understanding of what we're asking of you. For today's training event, I'm going to leave it in wind exposure B. Risk category. Truly, if you're doing this in a residential area, you'll pretty much always be in a risk category 1. If you happen to be building on an emergency service building, such as a police station, fire station, school, it could bump you up into risk category 2. If you're installing on a meeting hall that has more than 250 people assembling at one time, that could also bump you up into risk category 2. For today's training, I'm going to leave it at risk category 1. We're going to say this is in a residential area. Next item is your loading conditions at auto-filled with 100-mile-an-hour wind speed. Now, in some jurisdictions, they're still working off of ASE 705 for the structural engineering. Under ASE 705, I would really only have to design to an 85-mile-an-hour wind speed. But we want this tool to be utilized nationwide, which means we need to make it code compliant for the most stringent or latest structural engineering codes. So under the latest structural engineering codes, ASE 710, we're designing to a minimum of 100-mile-an-hour wind speed. If you call the building department with a street address to really make sure that you're designing to the proper loading conditions, you can add some snow loading in here if you need to, or you can adjust the wind speed if you need to. The next item down goes into attachments for our structure. Some things I'll note before I scroll down here, and if you'll remember, in this box at the top of the page, we have 60 attachment points in our project right now, 28 modules. The attachment points is really what I want to note at this point. And we're going to scroll down here just a little bit so we can see more of the page in the engineering. The next item down is our attachments. The tool starts off with a 4-foot spacing in our attachments. Pretty close attachment spacing. Every other rafter just about. It opens up with no attachment products. Now just note that if you choose none here on your attachments and you're going to use a third-party manufacturer's flashing product, take note that we're going to provide you in the balance of materials an L-foot that you'll mount on top of that third-party manufacturer's flashing product. If I was doing an asphalt comp shingle roof, I would probably choose the IronRidge FlashFoot as my attachment product. We're going to go ahead and use FlashFoot for our attachments right now in this overall project. Alright, the next item down, we start seeing the rail family here. We also start seeing what we call zones of the roof. If you're not familiar with what zones of the roof are, you can click on the question mark and we'll give you an explanation. Basically, zone 1 of that roof is everything within the exterior walls of the structure. Zone 2 is your eave overhangs of that structure or that roof line. Zone 3 is where the eave overhangs intersect each other in the corners of that roof. So just take note of the different zones of a roof. Now as we start looking at these different zones and then looking across at the rail family, we're seeing the maximum spacing that we can perform with that rail under our loading conditions for that project. So if we look at this XR100 rail that the design tool opens and utilizing, we see a cost factor of 29.16, and we see that we can do a maximum spacing in the attachments of 9 foot 7 inches. Pretty phenomenal. Even zone 2 of that roof, that eave overhang area, I can go 9 feet between my attachments. Now remember the tool started off with a 4-foot spacing between my attachments. I want to minimize the number of attachments in my project. Before we start adjusting anything though, I want to show you that we also give you the max cantilever. Remember, cantilever is the amount of rail that can extend beyond the last attachment point to the structure. So as I start looking at this cantilever, pretty phenomenal. That XR100 rail, in zone 1 of that roof, I can cantilever my rail 3 foot 10 inches. Zone 2, that eave overhang area, I can cantilever my rail 3 foot 7 inches. With today's fire setback rules in our array layout designs for a residential structure, pretty much we're never designing in zone 3, that eave overhang intersection area of the roof. So pretty much we're always designing for zones 1 and zones 2 of the structure. At this point, we can start playing around with a few different things. You know, we can look at cost factor. Maybe I want to go ahead and think about utilizing the XR10 rail. In that, you can see now that I'm at a cost factor of 25.77. When I was at that XR100 rail, I was at 29.16. So just by going to the smaller rail in the rail family, I can save quite a bit of money. Almost a couple $100 right there. Maybe I want to step up and use that big bad boy rail. You can see the cost increase going the other direction. Obviously a bigger rail is going to use more material to produce that rail. It's going to be more expensive. We're at $3,300 here. Definitely in this project, I don't need that big bad boy rail. I don't need that XR1000. I'm going to utilize probably the XR10 or the XR100. Now even the XR10 rail, I can do 6 foot spacing between my attachments very easily here for zones 1 and 2 of that roof. So I'm going to make an adjustment here now. I'm going to go ahead and I'm going to go with a 6 foot spacing in my attachments up above. And look at my cost factor now. I've dropped another $400, almost 300 and some, out of my project just by eliminating the number of attachments in my project. Now in that, you'll see a red flag came up here. I cannot span 6 feet in that zone 3 of that roof. Well, that eave overhang area, we're probably not even utilizing that space anyway. Truly, I can only span 4 foot 11 inches. You know what? The eave overhang is not even 4 feet wide. So I don't have anything to worry about here. So we can scroll back up and look at that toolbox at the top of the page. You'll notice that we've reduced 20 attachments. We're down to 40 attachments in my project. It could be that we have a very robust structure that we're building this solar system onto. Maybe I do want to bump up to that XR100 rail and look at the cost if I go ahead with an 8 foot spacing between my attachments. If I put 8 feet in here for my attachment spacing now, you can see I can no longer use that XR10 rail with an 8 foot spacing, but I can use the XR100 rail, and I'm down to 22.56. So it may cost a little bit more for the overall product. I was at 21 something here with the XR10 rail, but what I have reduced is labor in my project. If I scroll back up and look at my number of attachments, I only have 30 attachments. I've eliminated another 10 attachments in my project. Remember in those charts we were looking at earlier, the labor costs that we're spending on installing a solar system, a large percentage of our labor is spent on installing those flashing attachments. You know, even though I'm spending just a little bit more money with that XR100 rail, but I'm going to save in labor in my project. So you can see here very quickly you can toggle back and forth between a few different items and justify what is going to be the most cost effective for both materials and labor. So I think I'll leave it at the XR100 rail and a minimum number of attachments, going with an 8 foot spacing in my attachments. So a couple other things I want to point out down below here as we scroll down is we're going to provide you on this engineering document and engineering page a huge amount of useful information with the loading down here. It could be this is an older structure and you're going to do that 8 foot spacing, but you're not really confident of what the structure can actually perform and what the structure can take for point loading on that roof. If you're going to go to a structural engineer for review, this information right here will save the structural engineer a lot of time and headaches trying to figure out what the loading is going to be of the actual solar array on that structure. We're going to give you all the lateral forces. We're going to give you all the wind uplift forces, all the downward forces that are going to be applied to that structure. We're going to give you that for both the portrait section and the landscape section of your project. If you look at the very bottom here, we're going to give you some weight details that could be very useful information if you're going through an expedited permit process through the building department. Some jurisdictions will say, okay, no more than 45 pounds per attachment. And as you look here, you're at 44 pounds. Hey, I'm golden. I'm good with an expedited permit. Some jurisdictions will say no more than 3 pounds per square foot for your design. You can see here that we're at 2.6 pounds per square foot on distributed loading to that structure. Great information here for an expedited permit process or for going to a structural engineer for review. Next item is our options page in the design tool. Under the options page, you can go ahead and choose the length of the rail that you're going to provide in this project. Our stocking lengths are 11 foot, 14 foot, and 17 foot. These stocking lengths are based around the most widely used modules in the industry today in fitting 3 modules, 4 modules, or 5 modules with the least amount of wasted rail. It could be a very large commercial project you're wanting to do. Maybe you're wanting to use some custom length rails to minimize number of splices or something like that. You can actually order up to 20-foot lengths under custom cut lengths of rail. Now just note that if you go with a custom length, it's going to be an added charge for shipping, and there will be a time delay on actually receiving your product. So most people are just going with the stocking lengths if needed. This way the stocking lengths are probably readily available at your distributing partner of ours. Next item down is the grounding method that you're going to utilize. About everyone is using integrated grounding. It automatically comes up that way in the design tool. The integrated grounding comes with a T-bolt automatically, but you do have a selection here. If you wanted, you could go to an old style mid-clamp with a Wiley weave clip, or choose none and figure you're going to figure out your own grounding method. But about everyone is utilizing integrated grounding in the IronRidge product line. Next item down is accessories. If you're using microinverters or power optimizers, definitely I would get our microinverter hardware kit. Definitely makes a very quick installation with some T-bolts at the top of our rail to mount those microinverters or power optimizers. I would definitely utilize our wire clips for wire management. They snap very easily into the top of our rail to go ahead and install your wiring and perform your wire maintenance in your project. End caps. With the body shape of our rail, I would definitely add the end caps at the ends of the rails. Keep leaves and debris and rodents out of those rails. Next item down from there is finishes. In the finish selection on our product, you can go ahead and choose it in a clear, what we call a mill finish, or you can choose a black anodized finish if you want. A lot of people like the black finish, maybe with a black module frame. You can choose that black finish in all of the product lines here at IronRidge. The clamping hardware, the actual rails, or the FlashFoot attachment to the structure. Just take note that the XR10 and the XR1000 come as a standard in clear. The XR100 comes in a standard as clear or black on the rail selection. The next item is our quotation page. Under the quotation page, we have some great information at the top, subarray details. Truly, I promote prepping your rail on the ground before sending it to the roof. You'll notice here that we give you a required rail length, as well as giving you the dimensions of the rail that we've selected to provide you in your project. So here you can see that in the portrait section of the array, we're going to provide you 2 11-foot rails that you'll splice together, and you have a needed length of 20 feet 1 inch. This makes it very easy for you on the ground to go ahead, splice your rails together, and then use a chop saw and cut the rails to the proper length on the ground, and then send those rails to the roof ready for installation. So we give it to you for the portrait section and the landscape section. It just saves you from having to do the math and figure out the overall length that you need that rail to be for the project. And then the next item down is your balance of materials. No sitting at the plan table in the office and counting up everything you need for your project. This gives you down to the exact count of everything you need to order from IronRidge for mounting your solar array. So you can also go ahead and edit your balance of materials. It could be that you've done quite a few projects. You've gone ahead and you've utilized the cantilever strength of our rail on some past projects, and you've minimized the overall number of attachments in your projects in the past. So you've got maybe a box or two of flash feet left over from past projects. Maybe you want to go ahead then, and you'll notice where FlashFoot is located here in the balance of materials. You have 5 boxes that are needed for this project. I want to go ahead and delete 2 boxes because I'm going to utilize up those boxes that I have in the warehouse from past projects. Hit save. It's going to go ahead and show you the number that you've deleted, and it's going to show you the actual amount in your order for your project. Now note the packaging in some of these products. The module mounting hardware comes in packages of 4. So just pay attention that as you delete 1 in this count in the balance of materials, in some of these items you're counting multiple numbers. So in the mounting hardware, if I delete 1, I'm going to actually be deleting 4 of them. In that FlashFoot product, I deleted 2, which they come in boxes of 6. So I've actually deleted 12 flashings from the balance of materials for this project. So just note that it makes it very easy to go ahead make adjustments in the balance of materials if you want for your overall project. So I talked earlier about this all being suggested manufacturer resale price. Go ahead and contact with your distributing partner of ours. Find out what your discount level is from suggested manufacturer resale price. I'm going to be very, very conservative here. You're going to get some type of great discount from any one of our distributing partners, but I'll go ahead and put in a 25% discount and hit apply. The balance of materials now gives you suggested manufacturer resale price, but it's also going to show you your discounted price and actually what you're paying for the racking system from IronRidge for your project. Alright, the next page in the design tool is our next steps page, and this is truly has most of the same items that we saw in that resource page before we got on the design tool. You can go ahead here at this point and share your project with another design user. You can go ahead and print your project here. You can go ahead and download your project into a CSV file if you want. You can go ahead and look at different parts through AutoCAD drawings. If you don't have AutoCAD available to you, you can go ahead and download these drawings in a PDF file if you want. You can print out an install manual. That engineering document I told you about, you can go ahead and at this location not have to backtrack to that resource page. You can go ahead here at this location and receive your engineering document as well. We're California, we're doing flush to roof with the XR100 rail, and hit download, and this is that same engineering document that we saw earlier where you have an actual printed stamped engineering document. Provide that and have that part of your permit package. Remember that you have these detailed drawings below that engineering document as well to print out, have part of your permit package, and also go ahead and have that with your installers out as they're having inspections from the local jurisdiction. So just take note, this is the design tool. We went through a lot here in a relatively short period of time. It's a very user-friendly tool. You can design a system in just minutes once you familiarize yourself with the tool. You can't break the tools. Highly encourage you to go ahead and jump on here, play around with it, see how quickly you can go ahead and look at the different cost factors with the different rails in the rail family. Make selections between the attachment spacing and which rail you're going to use, loading conditions of your project with the spacing that you're doing between your attachments, with your distributed loading and your point loading at each attachment point. Awesome tool here for helping you design your projects. I'm going to go ahead and switch things around here, and I'm going to go back to our PowerPoint presentation, take up from where we left off, and let's go over some install notes. Just remember, you have a lot of flexibility with the different rails in the rail family. Choosing the rail that's going to work best for you in maximizing that spacing between your attachments, also allowing you to very quickly look at the loading that you're placing on each attachment in those weight details on the design tool. Remember to go ahead and try to take advantage of utilizing the cantilever strength of our product as per the bottom illustration here. Go ahead and stagger your attachments to that structure. That's going to maintain a very distributed loading to the structure, which is the best case for the structure itself. Remember that you should be checking with your module manufacturer. Our design tool will allow you to design your system with any module manufacturer in a landscape format. But just remember that with some of the smaller frames on modules today, some of the module manufacturers are not allowing their modules to be mounted in a landscape format. Remember all of the items that we have on our design tool to incorporate those into your permit package. The structural documents, the electrical documents, and the fire safety documents. Under the structural, have that design tool printout as part of your permit package. It's giving all the loading conditions for your project, showing that maybe you fit into an expedited permit process for the building department. Go ahead and provide a copy of the UL listing for our integrated grounding system and a tech sheet on integrated grounding, part of your permit package. Go ahead and print out the documents for our fire testing, showing that we have a Class A fire rating for our racking system as part of your permit package. Definitely on the permitting, don't forget to print out that engineering document and have that part of your permit package, and those detailed drawings. Try to go ahead and remember to have those with your installers out in the field during inspections with the jurisdiction. We know your whole process. We understand it very well. We want to provide you an awesome, very robust, strong racking system. But over and above that, we want to help you with the design process. We want to help you with all the permit documents that you're going to need. We want to go ahead and we've got an awesome lineup of distribution partners for you to actually go ahead to be able to go ahead and purchase our products. And then, like I said, our rule of thumb is really to have a simple product for you to utilize. It's very simple to install, very integrated to work with everything that you're doing. All right, let's go over some installation notes here quickly. As you get into building your project, don't forget to be safe out on the job site. Definitely, as you're standing up ladders to access the roof, definitely stand up that ladder properly, making sure that it's safe for personnel to get up on the roof. As you get up on the roof, definitely use your safety fall protection. Definitely have all the personal protection equipment. You're up on the roof or even on the ground, I'd be wearing that hard hat. Protect yourself from items that could be rolling off that roof. Definitely up on the roof, have your fall protection on. Have a good harness. Take care of your eyes when you're out on the job site. Wear your sunglasses. That UV sunlight will just tear up your eyes over a long period of time and years of installing solar systems. Definitely think about your body and take care of it as you're up there on working on these systems. I highly promote that you prep your rail on the ground prior to sending it to the roof. It's very easy to splice the rails together on the ground. If you drop a nut or a screw or bolt, very easy just to pick up and continue your work. If you do that on the roof, more than likely it's going to roll off into the gutter if you're lucky. In a lot of cases it'll bounce past that gutter and be on the ground, never to be seen again. Highly promote prepping your rail on the ground. Our rail is lightweight. It's very easy to send to the roof, pre-assembled, ready to rock and roll for your project. Definitely when you get up on the roof, start installing those flashing products. Go ahead and do your array layout. Go ahead and snap your chalk lines for your attachment locations. Locate those rafters. Go ahead and get your rails installed. Go ahead and get all your wiring performed. Get your grounding completed. Start installing modules. Remember, as you're designing your system on our design tools, we're going to give you those exact dimensions that you need to cut those rails to as you're prepping your rails before sending them to the roof. Also note, as you're doing your splices on your rails, the rails that you're going to provide as the grounding rail, you'll be installing the lay-on lug, your earth ground connection on that one rail, and at the splice locations in that one rail, you will be providing a bonding jumper at the splice locations. The splice piece comes with a self-tapping screw and is in one bag. In a separate package is your bonding strap the bonding strap comes with 2 star washers. As you're installing the bonding strap under the tech screws that come with the splice piece, make certain that that star washer is located between the rail and the bonding strap. That star washer is what's providing the UL listed grounding between the rail and the bonding strap. So make sure that you're installing that properly. If you have a continuous run of rail over 100 feet, which is probably only going to be on a commercial type application, but if you have 100 feet of continuous rail, at 100 feet you need to develop and build out what we call an expansion joint location. In an expansion joint location, you're going to go ahead and slide your splice piece into the first rail, install your self-tapping screw, and then you'll slide the second rail onto that splice piece without installing a second self-tapping screw. This is going to allow the rail to expand and contract at this point, leaving that inch spacing between the 2 rails. In an expansion joint location, we're going to provide you some different hardware for the bonding strap. We're going to provide you 2 T-bolts that you'll install that bonding strap in the top of the rail as per this illustration at the bottom. Remember, on the integrated grounding, as you're getting your rail ready to send to the roof, you're going to select one of your rails in a row of modules to place that lay and lug earth ground connection to, and if you have a splice in the overall length of that rail, this is the location where you'll place a bonding jumper at that splice location. The second rail no longer needs any grounding support. Alright, you get up on the roof and you're trying to locate those rafters. Several different ways of doing that. You can take the old hammer effect and do the rap tap tap on the roof. It's pretty easy to feel and hear the sound density of where the rafter is located. Primarily, I would probably look at the eave overhang areas and see if I could see where the rafter is located, and then measure from the edge of the roof to a rafter location and transfer that measurement to the roof for where my attachment points are going to be to locate that first rafter. Once you've located a rafter with your first attachment, it's pretty easy then to measure out where the rest of your rafters are going to be located on a 2-foot or 18-inch spacing between rafters. There are different instruments that are available in the marketplace, density sensing equipment, where you can actually, pretty much like a stud finder, where you can locate the rafters. Or just take note that if you drill your pilot hole and find that you missed the rafter, pretty easy to go ahead and use a piece of hard wire, bend it in a U shape, put it down in the hole where you missed the rafter, and then rotate that around in a circle until it hits the rafter. The upper part of that U-shaped wire is going to be your illustration as to where the rafter is located, from the bottom piece of the wire hitting the rafter below the roof line, as per this bottom illustration. And then go ahead and re-drill your pilot hole into the rafter at the correct location. One of the advantages with the FlashFoot from IronRidge is that we kept it 12 inches wide. So if you missed that rafter by an inch or more, most cases you're going to go ahead and the flashing is going to be wide enough, put a little sealant in that missed pilot hole location, and the flashing is still wide enough to go ahead and protect that missed hole location. Typically I would snap some chalk lines for my attachment locations. In the FlashFoot flashing product, it's 3 inches from the bottom edge of the flashing up to your pilot hole location in a course of shingles. So just when you're installing your flashing, do it as per the center illustration. You want to make sure you're getting that flashing all the way up into the 3rd course of shingles and installing it to where the bottom edge of the flashing is right even with the drip edge in the course of shingles. You can shove that flashing up a little bit further if needed, but just note that if you're shoving the flashing up into the course of shingles far enough to where the next course of shingles is riding up on that elevated platform, trim those shingles back so that it does not divert water onto the elevated platform of our flashing product. Remember, the FlashFoot product installs very quickly. Remember, you have those guidelines in the flashing product that's going to illustrate where the actual pilot hole is located. Saves you from having to put your head against that hot roofing material to visually see where the lag bolt is entering your pilot hole. And then it's a very simple installation. The lag bolt through the L-foot, put it into the flashing, tighten that lag bolt down, and that open slot L-foot makes it very easy for the rapid installation of the rail onto that L-foot connection. I don't know how many times you've installed solar systems, but If you don't have your very first module perfectly square when you install it, you'll find that after you get about 4 or 5 modules down, you might be running downhill with the modules or maybe uphill, depending on what type of skew you have that first module placed at. I've seen people do what I call stair stepping, and they'll realize that their modules are a little bit crooked, and they'll start fudging each module up a little bit, trying to maintain a straight line of modules. I don't recommend this. It really looks ugly. So what I recommend is that you go ahead and square up those rails with the structure, and then get your first module mounted square, and then you're golden. So here's a little trick on how to do that. Go ahead and get your southerlymost rail, the rail closest to the bottom edge of the roof line. Get that installed where you want it exactly. That 3-foot dimension is up to you. It doesn't have to be exactly 3 foot, but just make sure that that first rail is relatively square with the edge of the roof. Then go ahead, adjust that first rail with your fire setback for your solar array. There again, it doesn't have to be exactly 3 foot, maybe it's 2 foot, it's whatever the local jurisdiction is requiring for a fire setback from the edge of the roof. Then go ahead, tighten that first rail down exactly where you want it. Now go ahead and give yourself a measuring mark on all the rails in your array for that array layout. Could be 3 foot, could be 4 foot, doesn't matter, just as long as it's an even dimension and you've marked all the rails that same dimension. Now go ahead and do a diagonal measurement from your first rail locked in where you want it on that second rail, and then adjust that second rail back and forth until you achieve those diagonal measurements being exactly the same. Once those diagonal measurements are exactly the same, now you have that second rail square with the first rail. Tighten that second rail down where you want it there. You can go ahead and perform this up the rest of your array doing those diagonal measurements. Now you'll truly have all of your rails square with the structure. Once you've done that, go ahead and mark each of the rails with an 1.5 inch mark. That's what's required for the end clamp to go ahead and mount your modules. Go ahead and take a minute placing the first module, making sure the frame of that module is right on your 1.5 inch mark, and go ahead and tighten down your end clamps. Now you have your module square with your square rails. In doing that, now you can very rapidly place the remainder of your modules, and they're all going to come out true, square, and correct with the structure. Okay, as we're thinking about tightening down all of this hardware, definitely we want to tighten it to the proper torque spec. For all the module mounting products, it's 84 inch-pounds of torque. What I would do is I would go ahead and use a battery drill motor with a clutch. I would have my torque wrench with me on the job site. Probably put that at a medium clutch release setting on the drill motor, and then go ahead and install a couple pieces of attachment hardware. And then check it with the torque wrench. See what you're achieving at that clutch setting on the drill motor. If you need a little more torque, go ahead and adjust that clutch setting on the drill motor. Then go ahead and use the battery drill motor for the rest of your installation. You might do a random check occasionally with the torque wrench just to make sure that the battery drill motor is still achieving the proper torque setting that you need for the module mounting hardware. 84 inch-pounds is a minimum torque setting that's required by the UL testing for the integrated grounding. Kind of a little tip here on installing the mid clamps. I would go ahead and after you have your first module installed with the end clamps and you're bringing your next module in, get your module in close to where you want it, get all your wiring done, use those wire management clips for holding the cabling up properly. Then go ahead, get the module just about exactly where you want it, and at the last moment drop the mid clamp into place between the two module frames. You'll note that there is an indicator mark at the top of the bolt showing what position the T-bolt is in. If you turn the nut just a little bit, it'll turn the T-bolt into the correct position in the rail. Then go ahead and tighten it down with the drill motor. I've already talked a little bit on the torque wrench already. Definitely I would use a drill motor for installing the module mounting hardware. Go ahead and make sure that you're adjusting that clutch setting on the drill motor to achieve the proper torque level with a torque wrench. The battery impact gun, definitely use that for installing the lag bolts of your flashing attachment products. But once you're done installing your lag bolts from the flashings, go ahead and switch over to the battery drill motor with a clutch for installing the rest of your module mounting hardware. All right, I want to thank you very much for joining in on the training presentation today. I know it's hard to find time to go ahead and join these training presentations, but truly this is why we place these recorded trainings on our website. Unfortunately, for the recorded trainings and not being interactive, being able to ask questions, this is not a training event where I can give you continuing education credits from NABCEP. If truly you're after some continuing education credits from NABCEP, join in on one of my live training events where we can be interactive, you can ask your questions, and I can give you answers to those questions. From watching this recorded training presentation, if you have any questions, don't forget to call our tech support group at 1-800-227-9523. Our tech support group will be glad to answer any questions you might have, whether it's in using that Design Assistant tool or with product questions. Definitely we're here to support you every way we can, and I look forward to hopefully having you on one of my live training events as you can make those times and dates. All right, thank you very much.